Alright, last thing here we have is a geometric series. The sum of the terms of an infinite geometric sequence is called an infinite geometric series, or just simply a geometric series. So if you're actually given the numbers separated by pluses or minuses and not commas, this is a series, and we would use the formula a sub 1 is equal to a 1 over r. So all you really have to do is just find your first term and your ratio, and you can take your first term divided by 1 minus your ratio. This will give you your sum. So if we look at example 7, and if we want to find this sum, we're going to say S sub n is equal to a sub 1 over 1 minus r. Then we need to identify our a sub 1 and our r. So your r is going to be just the 1/2, which is attached to the n. It does not include the 5. And your first term is what you get when you plug a 1 into your equation. So, or sorry, not a 1. You get your first term by plugging in whatever your first term here is, which is a 0. So we're going to say 5 times 1/2 to the 0 power. Well, 1/2 to the 0 is just a 1, so we're going to have a 5. So if we use these numbers for our sum, we're going to say 5 divided by 1 minus a 1/2, which is equal to a 5 divided by 1/2. And if you have to divide by a fraction, or that's the same as multiplying by the reciprocal, so that you can get rid of that fraction in the bottom, and you end up with just a 5 times a 2, which is 10. So your final answer, your sum, is going to, from 0 to infinity, your partial sum here is going to be your sum is actually 10. Now we can do the same thing for B, where we look at our ratio, and we're still going to use the S sub n is equal to a sub 1 over 1 minus r. The good thing is we already know that our first term, a sub 1, is 5. Well, how do we figure out what our r is? Well, remember, you can always find your r by taking your one term divided by its previous term. So if we take a sub 2 divided by a sub 1, this will give us our ratio. So we're going to take a 0.5, which is a 1/2, and we're going to divide that by 5. So if you have a 1/2 divided by 5, that's a 5 over 1, you multiply by a 1/5 to simplify this fraction, and so these cancel. Your ratio ends up being a 1/10. So we have our a, we have our r, so we're going to plug these in. We're going to say our first term, which is a 5, divided by 1 minus the your ratio, which is a 1/10. So that will give us 5 divided by 1 minus 1/10 is a 9/5. So your ratio is not just 9. Don't get too confused here. We're going to multiply top and bottom by a 5 over 9. 5 over 9. So, oh, goodness gracious, that's not a 5. Let me back up. There should be a 10 here. I'm getting confused with my 5s. There we go. So let's multiply this by 10 over 9. That looks a little bit better. Multiply the top by 10 over 9. So you can cancel out your denominator. 5 times a 10 gives us a 50 divided by 9, and you can just leave that as a 50 over 9. So as long as you figure out your ratio and your a sub 1, and as long as you don't confuse your fractions like I did, you should be able to find your sum of your infinite geometric series rather easily.